Hey everybody, this is Dr. Duncan. Welcome to part 4 of our exploration of sea level rise in the era of climate change. What we're going to focus on now are what are known as adaptations to sea level rise. Adaptation is more generally the process of adjusting to actual or expected climate and its effects. In human systems, adaptation seeks to moderate or avoid harm or exploit beneficial opportunities. In some natural systems, human intervention may facilitate adjustment to expected climate and its effects. This, of course, I piggybacked here on the definition of climate adaptation from the Intergovernmental Panel on Climate Change. But in essence and in short, adaptation is our response to climate change. How do we cope with it? And there are a variety of ways that we can cope with sea level rise. I'm going to have you watch two videos. The first is featuring a researcher, a landscape architect and engineer from University of California at Berkeley, focusing on the problems that sea level rise presents for San Francisco and some of the possible ways to adapt that are being explored by the community there. And then the second video I want you to watch is this one. This is from Verge, which is a science news organization, and it's focusing on city adaptations in general, with a particular focus on New York. But it also focuses on a couple of other communities in the U.S., including South Louisiana and also communities up in Alaska. So go ahead and pause this video lecture and navigate over to the PowerPoint that is associated with this video lecture and find these slides and click on the images to launch the videos. They're short, they're only about 5, 6, 7 minutes or so, and then restart this screencast, and we will cover some of these different types of ways that we can adjust to sea level rise along the coast. Okay, welcome back. We're going to look at some of the ways that humans are adjusting to sea level rise by re-engineering the way we live on the coast. One of the most common approaches is to do what's called coastal armoring. And you see a couple of examples of that here. First of all, you see that the land is being protected by a thick concrete wall here. And then the land behind the wall has been filled in with fill material to sort of raise the elevation. And the third component that we see in this illustration is that there are rocks that are put in front of that wall. Those rocks basically break up the wave energy so that the waves are not slapping hard against the wall and threatening its structure. So those rocks are breaking up that wave energy. So those are just in this one diagram showing you 3 different ways that we can armor the coast. Some of the benefits of this is that coastal armoring can be effective, and it will be necessary in protecting much of the built environment, places that we do not want to retreat from. The downside is that this is very expensive, and it's also winds up destroying a lot of coastal ecosystems that are at that margin of the land and the ocean, and substituting them with this gray infrastructure here of concrete and rocks. Okay, so that's one approach, is coastal armoring. Another approach, as you saw in a couple of the videos, including the one from South Louisiana from Al Jazeera, is that buildings can be raised, which is kind of mind-blowing when you're first introduced to the idea that there's ways of actually engineering this so that you can lift buildings up and then put them on pilings that essentially have raised them hopefully out of the reach of storm surges and flooding. This is not cheap. This is not the sort of thing that your average citizen will be able to do along the coast. It's quite an expensive process. Another way to adjust to this is simply for cities to require that when new buildings are built, that they be built at a minimum elevation. to reduce the chances that they are flooded. This is done at the local government level, either at the city or the county, in the development of these things that are called building codes. Perhaps you've heard people talk about building codes before. And those are essentially the government's way of saying, here's how you must build if you're going to build, in order to, in this case, ensure that whoever is going to live here has some protection from a known threat. In that case would be sea level rise and flooding. There are some communities that are turning to more innovative approaches, and here's one of them. It's called floating infrastructure. It's basically building a house on a platform that rises up and down with the tides, and also rises up and down when there's flooding. This, of course, can't work everywhere. It has to be in sort of quiet backwaters. Otherwise, these structures are going to get rocked by waves all the time. I've seen this in Seattle, Washington, and I also know that this is employed in some places in Europe. It's not super widespread, but it is a possibility in some communities and more than others, and it's something that we're going to be seeing more of into the future. We already know how to engineer these things and how to make them work. Another approach to this isn't as sexy as some of these other examples, but this is basically upgrading our stormwater systems. Stormwater systems are a series of pipes that we have underneath the built environment that capture excess rainwater and that can't soak into the ground, or that falls on our parking lots and roofs and other impervious surfaces like that. And these stormwater systems basically capture this water and typically take it down to the nearest creek or river, or if you're along the coast, dump this out into the estuary. And the problem is that a lot of our stormwater systems are old, and they were not built for the heavy rains that we now are getting as a result of climate change. And therefore they wind up backing up during periods of heavy rainfall. These piping systems can't get that water out of the built environment quickly enough, and so the water accumulates on the surface and causes flooding. The other problem is that with more narrow pipes, they tend to get blocked by garbage and leaves and branches and things like that. That can cause a backup and flooding. So by increasing the diameter of the piping through our stormwater systems, that's one way of many ways that we can improve these systems to help us be more resilient and resistant to flooding. Another way to cope with sea level rise, especially when storms are coming, is to build the landscapes so that it can withstand the flooding that you know is inevitable. And we see that here with this diagram. In the top panel, we see how such an environment would function. You see there's people out enjoying the water. You've got some walkways along the shoreline here. That would be an armored some coastal armoring there. That's a seawall. You can see it continuing in the background there. You've got like a slope here. You're raising the elevation gradually through here. You've got some vegetation in place to hold the soils in place. Some more park-like type features, walkways and stuff. Here we got some bike lanes and so forth. You'll also see that the interstate here, or the highway here, is elevated. So all of that to protect it from when storms do come ashore. If you have, for example, your highway closer to sea level, then it's going to get flooded and some of these structures can get destroyed. This is what the bottom panel, of course, which you've already been looking at, I'm sure, shows what would happen during a flood event where you got a hurricane moving a storm surge ashore. And you see that the waters cover up the park, which is too bad for the park. It's going to be messy and stuff, but it's not threatening people's lives, and it's also relatively cheap to rebuild any of that structure that gets destroyed during the flood. And in fact, if they built it well, there won't be that much destruction. It will be mostly a lot of cleanup. And you'll notice that the built environment, the heavy built environment over on the far right, is protected by this essentially wall that is a park and greenway, protecting against the storm surges that you would get during a flood. And this is the kind of thing that large cities like New York and others are contemplating and planning for in order to prepare them for sea level rise. Another possibility, though, is not defending the areas where we live now, but instead giving up on living in these areas and moving out. And this is what's known as managed retreat. Here we see a house that's being taken out from a coastal wetland area because of chronic flooding, and this family has relocated. Managed retreat is something that it's inevitable in many communities, especially those that are very close to the high tide mark now. So therefore they're very vulnerable. We're already seeing managed retreat. And what I want you to do is to watch this next video that sort of walks us through an example of managed retreat in southern Louisiana. It's about a community that is being relocated further inland where it's safer from the flooding. This is from the PBS NewsHour. So go ahead and pause this video lecture, navigate through PowerPoint to this slide, and click on the image and it should launch the video. Or you can find the link on Moodle associated with this class. Okay, welcome back after watching those videos. This is just one example of one community here in the US. Let's take a look at another community, this time on the East Coast. This is Norfolk, Virginia, and this is a diagram illustrating its master plan for responding to sea level rise. Norfolk is taking a very proactive approach to sea level rise. It's particularly vulnerable because much of the city is at a low elevation. The four colors here represent different zones of the city and how they are planning on adapting to sea level rise as a result. The red areas are part of the city that is essential to the city's economy. It includes the tourist region down here at the lower left, as well as a Navy base that's up here at the top left. And those are deemed essential, and the city, in working with the state and federal government, plan on defending these areas. That's going to involve probably a lot of coastal armoring. Other areas, however, are more at risk of sea level rise, and really they're going to be abandoned. That's the areas that are highlighted in yellow here. The city simply does not have enough funding to defend these neighborhoods that you see here in yellow. People are living in those neighborhoods. There's thousands of homes and thousands of people that live there, but there's simply no way for the city to have enough money to armor all that coastline, as well as to put in the essential infrastructure like the stormwater systems and raise buildings to higher elevations and these sorts of things. And so in those communities, people are not going to be evicted, but they're going to be allowed to adapt to sea level rise on their own, which right now for the very near future isn't going to mean a lot of change, but down the line when we're looking at a couple of feet of sea level rise, what we're going to see probably is that these communities are gradually going to be abandoned. Meanwhile, the areas that are in purple and green are at high enough elevation that these areas should be protected from up to moderate levels of sea level rise. The purple areas are established neighborhoods where there's already well-developed communities with good infrastructure and good community assets in place. The city is committed to ensuring that these areas are protected and are maintained, and that have connection to the other parts of the city that are also going to be protected and maintained. The areas in green are areas of the city that are underdeveloped and yet would also be at low risk of flooding in the future. A lot of these are underserved communities that the city realizes that it needs to invest more into. The city's looking into developing or encouraging high density, mixed use neighborhoods. That's a mixture of both residential and commercial. And making these neighborhoods more livable by making them walkable and with parks and all the amenities that everybody everywhere should be able to enjoy in a city. So this is essentially the city's master plan. Some areas are to be defended, other areas are to be increasingly developed, and other areas will have to adapt on their own or undergo some form of managed retreat. There are many other things that go along with adapting to climate change for communities that are not necessarily represented here. I've made a short list of a few of them. These responses include improved emergency preparedness. That's what it sounds like, being ready for when flooding does happen. Improved risk management is reducing how at risk your community is. Everything from the people to the infrastructure. If you minimize that risk, you have less to have to worry about when a disaster strikes. Other approaches involve diversifying where you're getting your drinking water from, and especially seeking out places that will not be subject to saltwater intrusion. Something we're going to talk about later on in this unit is using coastal wetlands to absorb floodwaters to reduce how bad storm surges can be. And overall, should be planning with climate change in mind. And that means, for example, that when there's new developments in the city, new things to be added to the city, that they are designed and developed thinking ahead about how the climate of the future will be and how at risk an area will be in terms of flooding. And then finally, whenever an upgrade is needed to essential infrastructure like stormwater systems, or maybe there needs to be a new school or changes or repairs to schools or other infrastructures, then do those upgrades and those repairs in ways that will make the built environment more resistant to flooding and resilient to flooding when flooding does occur. Okay, we're going to end this section of our exploration of sea level rise in the era of climate change. And in part 5, we're going to look at the cost of rebuilding and the cost of having no adaptation whatsoever. We're seeing that play out on the Alabama coast.